All right, so in this video, this is the second video in the sequence on malware analysis with machine learning. All right, so if you haven't looked at the first video, I suggest you do that first, as I went over the theory, and I discussed the lab. So I'm just gonna really quickly summarize the objective of the lab here, and then I'm just gonna get into the feature extraction part. All right, so as you know, with the machine learning pipeline, you have the data, you have feature extraction, then you have, once you have the vector space model, then you do the machine learning and evaluation. In this case, we're going to extract features from a set of files that we have. So remember, this problem is dynamic analysis of malware for malware detection. So it's going to be a two-class problem. Basically, we have malware and goodware, right? So, or non-malware. So malware is anything like a computer virus, is some kind of code. So we already had some executable files, like a virus malware called Bad Rabbit. We run it, right, in a emulator, and the emulator produces a set of log files. So for each virus file, we have one log file. Now, because it's dynamic analysis, that basically means that the file runs in the emulator, and everything it does, a system call, calling libraries, etc., is recorded in the log file. So here we can see, if we go, so in your lab, when you do this lab, you will have this folder, log files. All right, so it should be in your VM, or it should be a set of files that you download. So if we go over here, we can see in this log file, if we do ls-l, we can see a list of all the files. As you can see, this basically means that we had 3 good executable files. We ran them through the emulator and obtained these log files. And then here, when we ran the malware, we ran them through the emulator, and then every time we ran one, we obtained a log file, such as this one. All right, so this is the log file. Basically, we have some kind of a vocabulary, right? Because at the end of the day, they're all using the Windows environment, which means they're using, a similar structure of registry calls, reading files, reading DLLs, etc. Right, so let's look at just one of these. So for instance, if I do nano bad rabbit, right, and I do that, and as you can see here, this is the log file with the set of the different things that the executable did, right? So there was a process involved, an operation, a path, a result, and a detail. So all of these words are of interest to us, right? So because we're going to look for specific values or specific keywords that might be associated with malware, and would help us to develop a machine learning algorithm that can classify between malware and goodware. So as you can see, we are calling, different files, different objects here, and so this is what our vocabulary will consist of. Okay. Now the same applies for the goodware. We do nano good, right, and you can see there it is. And so you can see again, we have some goodware files as well, right? And so we record this information. So this is the dynamic behavior of this file as it was being executed in some type of an emulator program. All right, and so now that we have that, so we have, these are our inputs, right? Now we want to take all of these files, as I said, figure out a common vocabulary, that is, a common set of words that appear not in all of these, but basically what we want to do is we want to extract all the words that appear in these files, right? So we'll take all the words that appear here, right, and add them to the list, and all the words that appear here that are that we didn't have before, and add them to the list, and we take all the words from here that we didn't have before and add them to the list, and then we take all the words from here that we didn't have before and add them to the list, and so on. All right, so we're just creating a list first of all the words, and then once we have all the words, obviously some of those words will appear in this but not in this, and that's fine. All right, because that's really what we want to keep track of. So again, if what I suggest to understand this is the bag of words approach. go back to the previous video and try to understand the logic with that. All right, but that's really the idea. So we take all the words in all of these files and we create basically a set of words that defines the vocabulary, and then we measure how many times, one of those words appears in this file, and then the next word, how many times does it appear in this one, and so on. And we keep track of that. All right, and so that's the goal that we want to do. Now, you could always code that by hand and do it easily, but instead of coding it by hand, we're going to use a technique called the vectorizer. So we're going to use the count vectorizer from our sklearn library. All right, so this is an sklearn feature, and it's actually pretty simple code to write, so it shouldn't take that long for us to complete. Now, keep in mind, I only have 3 files here of badware, and then I only have 3 files of goodware. That's just to speed up the process in this video. Later on, when we do the machine learning part of this, we will just take the file that represents all the files in our data set, so all 142. So we've already done that part for you because it does take a little bit of time, so that will be also a link in your lab so that you can just download the finalized data set for machine learning. But here I'm just showing how we extracted the features. All right, so I'm going to start coding this script. Should be a pretty straightforward, so I'm going to go up 1 level. All right, I'm going to clear this. I'm going to do ls-l. And now I'm going to just write my own script. So I'm just going to call it nano malware vectorizer. So malware vectorizer.py. All right, so there's my script. All right, and I'm going to import a few libraries. So I'm going to do import OS. I'm going to import pandas because we are going to use pandas for data frames. So I import pandas as PD. And then from sklearn.feature extraction.text, we are going to import count vectorizer. All right, so from sklearn feature extraction.text, we're going to import count vectorizer. All right, so these are our files. Count vectorizer is basically what does the bag of words approach. Then I'm going to specify the path, so I'm just going to say path equal log files, and that's just where the files are located in this directory. I'm going to create 2 lists, a list of the labels, right? So this is, technically like my Y, right? So this is the information for the classes. Labels is just a list, blank at this time, and then text. So what I'm going to do is I'm going to take, so imagine the following. I'm going to do the following. So let's imagine I open this here, and then I'm going to close it over here. So usually the way that you could do this problem is you could do, the car goes, right? And then comma, the house is green. And then you can say, I love machine learning. Right? And so on. So we could, we would create this type of inputs for the count vectorizer. Since we have malware files that are really long, and they're basically a whole bunch of rows and things like that, we're going to treat the contents of each file as just one extremely long string. All right, so basically then that means that this is going to be like goodware1.txt. That the whole contents of it will be in there. And then the next one is going to be goodware2.txt. And then the next one is going to be malware1.txt. So we're going to extract all the information in that log file for the malware1, get rid of the commas and things like that, and then basically treat it as a very long sentence, right? And is this the best approach? Maybe not, but this is one approach, right? So you can think of this problem in many ways, and you can always tweak this part, for instance, this logic to be a little bit different. That's certainly up to the developer of the code, but the simplest way to do it here is we're taking the entire file and we're treating it as a one single sentence. All right, so that will be the approach. Okay, so obviously we're not going to do that by hand. We need to do that through code. And so initially we're just going to leave the text list blank. Okay, now that we've done this, then we have the next step. Okay, and obviously this is where we're going to read the labels and we're going to read the file. So to write this code, we're just going to use a simple for loop for file name in os.list directory, and we're going to provide the path here. Okay, so then 1, 2, 3, 4, and I'm going to do if good in file name. So if good in file name. So remember that this for loop is grabbing all the files, goodware1, goodware2, goodware3, into a list, and then it's going to iterate through them. So we're going to check the value in file name. So we're going to say if good in file name, then basically it's one of the goodware files that we just grabbed, right? And so that means that the label, so 1, 2, 3, 4, the label will be, so labels.append, and we're just going to designate that the class should be 1. So you need to remember that this means goodware. Else, if good is not in the word, then basically in the file name, then it basically means it's badware, right? So we're just going to say actually else, and then indentation 1, 2, 3, 4. We're going to say labels dot append -1. All right, so that way we created the labels for each record that we are reading. All right, once we're done with that, the next step is to actually read the whole contents of the file and convert it into a sentence, and basically once we've converted it into a sentence, add it to the list called text, as I explained earlier. So to do that, I'm going to create the file with the path. So I'm just going to say file name is going to be equal to os.path.join, and we're going to join path, comma, file name, and then we print file name if you want to view it. So you can print just to make sure that this works. So you can say print file name. Okay, and then once we printed file name, we can actually go ahead and read the file. All right, so we're also going to use UTF-8 encoding so that we can get rid of any strange characters. So sometimes when you read certain files, the files have certain hex values or things like that that break the code. And so usually the simplest solution to that kind of a problem is just to filter out those terms. So here we can do with open file name, comma, encoding UTF-8 as F. All right, so we create an object F, which is basically we open the object with the name file name, and we specify it should be encoding UTF-8. All right, and then now 1, 2, 3, 4. 1, 2, 3, 4. We are ready to read in the contents. So we're going to read in the contents of the entire files. Let's say we grab malware2.txt or CSV, and we read the entire content. So we do f.read, and then we have it here. And so now we can call content.replace. So this content replace is, again, as I said, part of machine learning is cleaning the data. Here we're going to have some commas. We don't really want those commas in there, or we don't want double quotes or things like that. So you can always, and there might be more characters that you want to filter out. I leave that to you, but basically that would be the idea. So you do content replace of comma, and then we replace all commas with spaces here. We repeat this, content replace. We're also going to replace double quotes. So if we're going to replace double quote, actually, we can put that in single quotes. And we replace that with just blank space, and so on. You can keep doing that. Once we think we've cleaned up the input, then we can read it into text. So we're just going to do text.append, and we plug in content. So basically this, remember, this means, convert file contents into a sentence. And that's it. So once we've done this, we've created our labels. So we have our labels done and we have our text done as well. All right, so now the next step is we are almost ready to call count vectorizer. So we're going to use count vectorizer now to create the vector space. So the first thing we need to do is we create a vectorizer object. So we're going to do vectorizer, all right, which is going to be count vectorizer. Now usually in NLP, you remove stop words. So I'm just going to keep that in there. Stop words, English. And stop words are words like the. So it's very common words that add very little meaning, or semantic meaning. So we do stop words here, English. All right. And then we can do. Now the next parameter is actually really important. Now, whenever you're doing an NLP problem, or here in malware, you may end up with, if you have, let's say, millions of files, right? You could end up with usually the English vocabulary might be like between 70,000 and 100,000. But here, because we're talking about malware, these are not actual words. These may just be sequences of characters and so on. So you could end up with many, many more, 300,000 or so in individual unique grams or words or whatever you want to call them, blocks of characters separated by spaces. So you may end up with a lot of them, but you really don't always want to use all of them, right? You want to use really the most frequent ones, and that's really the key. So the next parameter sets up a number that defines a cutoff. How many words are you going to use? So it's always going to be the most frequent word. So for instance, for our example, I'm just going to do 1,000. So you might ask the question, so how do I know if I should do 1,000, 100,000, 15,000? Well, the way that you decide is with the machine learning, right? So once you've created the vector space, you're going to run it in your sklearn or TensorFlow, and you're going to analyze the performance of this supervised learning problem. And then once you analyze the performance, then you can say, okay, the performance is really poor. Maybe it's because I'm only using 1,000 terms. Maybe I should use 5,000. And so really here, this max features becomes a tuning parameter. It's a parameter that you really have to play with to see if you get good results. Okay, but for now, I'm just going to leave it to the most. Obviously, you don't want to use all the words that will create a really large matrix. So the smaller it is, the better. And so I'm going to start at 1,000. And you could always play with this in your lab to see if other max feature settings give you better results. All right, so once we specify, so this should be max features, all right, equal 1,000. So once I have this defined, all right, so now I'm ready to proceed. So I'm just going to do the transformation. All right, so I'm going to create an object. I'm going to call it DTM. All right, I'm going to create an object DTM. I'm going to apply vectorizer to it. So I'm going to say vectorizer.fit transform. So remember, this is from the SK library. So I don't need to train and apply. I'm just going to perform both tasks at the same time. So this is what's going to analyze all the vocab. It's going to take everything in text, right? Everything in text. Remember, that's the contents of every file treated as a sentence. It's going to extract a list of the 1,000 most frequent words, and then it's going to see, okay, for every file, how many times does this word appear in it? So it's going to count them. All right, so you do that with vectorizer fit transform. Okay, the input to this will be text. So you give it text, and then it's going to give you the data frame. DTM's, like a data frame. All right, so now you have data frame matrix or whatever. Now we have this, and the next step now is to create a data frame with pandas. All right, so this is, as I've mentioned before, pandas is a very powerful library for data manipulation. All right, and so we want to create now our matrix with the labels and the X data. So we're going to create this matrix, and then we're going to write it out to a CSV file. Okay, so we're going to use pandas for this. So I'm just going to do df, okay, equal pandas dot data frame. So pandas, or PD dot data frame, open parentheses, close parentheses. The input to this will be DTM. So this DTM here will be the input to this pandas frame. I'm just going to say DTM dot to array to convert it into an array of appropriate formatting for pandas. Okay, once I do that, comma, I need to specify what I want as the index in the frame. So the index in the frame will act as the first column. All right, and that's where I really want the labels, for instance, right? So in that first column, I'm going to want the labels. So I'm just going to say index equal my labels. All right, so that's that basically all those values in that label will be an index, and they're aligned with the rest of the data. For the columns, I want to give it names as well, and it just so happens that remember in the video example, right? You create the labels in the first row, and then the first column is sorry, not the labels, the name of the features in the first row. So if you think of a matrix, right? So let me write it over here. So it's something like this. So labels, comma, and then it's feature 1, feature 2, feature 3, and so on, right? So then what I did here with index labels is that I set this first column to be the label. So it was 1, 1, minus 1, minus 1, and so on, right? These are going to be comma separated. And then this will be followed by the X data, right? So this will be followed by whatever the vectorizer does. So the count. So let me actually say something like count of F1, count of F2, count of F3, right? Dot, dot, dot. And then again below, oops. We create this matrix. These are the counts. The first column is set out as the labels with the corresponding values, and then the first row has the features. So this, for the first file, this one, which is a goodware, we count how many times F1 appears in it, how many times F2 appears in it, and so on. All right, so that's what we're creating in the data frame. Right, so that was just an explanation of it. So now we can proceed. So again, I create with pandas data frame, DTM to array, index is labels, and then columns is going to be the names of the features, right? So we're going to do the names of the features in columns. So for that, we can call vectorizer. Vectorizer already processed that data. So we can say vectorizer.get feature names, open and close parentheses. To make this a little bit more readable, I'm going to use the backslash here. And that's really the hardest part of this. We also want to name that first column, so currently it doesn't have a name. So to do that, we can simply do dataframe.index.name. And we call it something like labels. Once we've done all of this, we are ready to print out our CSV. See how fast and easy this was? I mean, it's in less than 20 lines of code, probably, we were able to go from all the information in the log files, malware, and goodware, and we obtain our file ready for machine learning. So I'm going to do df.toCSV, and then we just say R in single quotes, and we give it a name. So I'm going to call this, let's just say dynamic malware matrix. Okay, .csv. And this one is definitely a CSV file. And that's pretty much it. We'll create our output file. If we want to print out the feature names for whatever reason, we can also do that. We can create, we add a little bit of code. Maybe you want to visualize them. So you can say features list, and we assign to it vectorizer dot get feature names. So get feature names. And now we just iterate through this. So we do feature for feature in features list 1, 2, 3, 4. Print the feature. We're going to typecast it to string, and I'm just going to say feature. Okay, and that's it. So that concludes this writing of the code. Now we're just going to run it. So I'm going to do one last print here. Print done. All right, so let's try. Let's see if there's no typos or errors. So I'm going to go ahead and execute the code. So I'm going to type Python. All right, so in this part, we got an error here. The encoding didn't work. So instead of rewriting this, I'm just going to take it out. And then basically, now you would have to come here to where we did all these replace characters. We can write maybe a regular expression. And then the regular expression could be used to get rid of like hex and things like that. So let me go ahead and just delete this first, and let's just see how that works. So I'm going to run the code again. All right, and now it's working. So now that the code finished, it finished processing the files, and you can see it's also printing out all the features. So all these words that we're seeing here that are being printed out by that last for loop are all the words, the most frequent 1,000. Notice that a lot of them are numbers. Now, usually in an NLP problem, you would probably want to get rid of these numbers, but in a malware detection, these numbers may actually have meaning, and so it might be better to leave them in here. I mean, they are obviously frequent. We know that already. But you can see also that there are words in here that are the most frequent. You can see that the word DLL does indeed appear. DLL this, DLL host, etc. So anyway, so this, these are all the features that were extracted. All right, now once we are done, we can go ahead and just we can clear here and just look at the output. So now you can see that there it is. Dynamic malware matrix CSV is our output. Is got this size here, right? And so we can look at that file. So I'm just going to do nano dynamic malware, print it out, and we can see that we have indeed the first row is the name of the labels that are the most frequent. You can see a lot of them are numbers. The next following 6 rows are actually the 6 files, right? So the first column is the label. So we can see here the first one is malware, then goodware, 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 then malware, malware. All right, and we have that, and then we have the count. So some are 0 valued and some those have appeared several times. All right, here we start to see some words now. We can see that the words, these are the most common words past the set of numbers. So you could choose to get rid of the numbers and just use the words. That's one approach. We could use more features, a cutoff of 2,000 instead of 1,000. That's really a choice for the, data scientists. And that, in fact, is what makes machine learning difficult, right? So it's not so much that we're using TensorFlow or the machine algorithms, but the difficult part is this. This problem, what we're taking on right now, it could always be improved because it doesn't matter. So, and this is a good point for me to say. It doesn't matter how powerful your machine learning algorithm is or your deep neural network. If you have bad features, you're going to get bad results. So it goes back to that classic saying, right? That garbage in, garbage out. It's still very much the data scientist's job to figure out the right set of features. Now, with deep learning, the only advantage is that because of it's designed for big data, instead of giving it only 1,000 terms, we could give it all the terms. And because of its power, we could expect it to be able to figure out the top features by itself. But I'll leave that for a separate discussion. For now, we just wanted to extract features from log files and take something like the bag of words approach for it. So here we go. That's the output of the file, right? So that's that basically completes this the feature extraction part of this sequence of videos on dynamic analysis of malware using machine learning techniques. In the next video, we are going to take now this data set that we extracted, right, and use machine learning algorithms to see how it performs. All right, keep in mind, we only did this for 6 files. In the next video, we will use the lab provided data set. All right, so that data set consists of 142 files. All right, so we will perform the data set is pretty much balanced. And so we are going to just analyze it and see our results. So for this sequence, we're going to do it with Weka, with sklearn, and with TensorFlow. All right, so this concludes this video.